Remember playing the game Guess Who? You know, where you try to figure out a mystery person by asking yes or no questions? Well, what if I told you that the winning strategy for that simple game is the exact same logic that powers some of the most sophisticated AI in the world? It really all comes down to one thing: asking the single, smartest question every single time.
So here's how we're going to break it down. We'll start with that guessing game, then we'll figure out how to teach a computer to play it. We're going to uncover its secret weapon, this idea called purity, and see how it scores questions to build out a decision tree. And then we'll connect it all back to see how this one simple idea is, well, kind of shaping our world.
All right, so let's start at the beginning. You've got this board full of characters. Your opponent picks one. Your job? Figure out which one it is and do it in as few questions as you possibly can. Sounds pretty straightforward, right?
A pretty common first question is, does your character have glasses? You know, it feels like a solid move. It splits the board, you get to flip down a bunch of faces, and you feel like you're making progress. You're narrowing things down.
And this is where it gets really interesting. Is asking about glasses really the most efficient way to start? I mean, what if only, say, 3 characters on the whole board have glasses? You're not actually eliminating that many options. See, the secret to winning isn't just about asking any question. It's about asking the smartest question you can at every turn.
Okay, so let's shift gears from the tabletop game to the computer. How in the world would you teach a machine to play this? It can't just look at the board and have a gut feeling. It needs a cold, hard mathematical strategy. It needs an algorithm.
And that strategy, my friends, is called a decision tree. At its heart, it's basically just a flowchart. It's the computer's roadmap for playing a super complex version of Guess Who. Only now, the characters could be anything from, is this email spam, to will this person default on their loan?
So, here we are back at that same critical problem. Out of maybe hundreds or even thousands of possible questions or features in the data, how does the algorithm pick the absolute best one to kick things off? It doesn't have intuition. It needs a number. It needs a score.
And the way it gets that score is through this beautiful concept called purity. This is the key to everything. The whole point of asking a question isn't just to get a yes or a no. The goal is to create new groups of data that are as sorted and unmixed as possible.
To really get this, let's forget about the game for a second. Just picture a big pile of fruit. You've got apples and oranges all jumbled up together, and your job is to sort them into separate piles. In the world of data science, a pile that's all apples would be called 100% pure. There's zero uncertainty. If you reach into that pile, you know for sure you're getting an apple. So purity is just a way of measuring how sorted or unmixed up a group is. Our starting point is usually something like this: a low purity or impure group. It's a 50-50 mix. It's a total toss-up. If you reach in, you have no real idea what you're going to pull out. This is the state of maximum confusion, and it's exactly what the algorithm is designed to fix. Now this, on the other hand, this is the goal. This is a high purity group. Sure, it's not perfect yet, but it's way, way better. If you had to put money on it, you'd bet you're going to pull out an apple. The algorithm's entire job is to ask questions that turn messy, low-purity groups into clean, high-purity ones. So how does this help the computer pick a question? Well, it scores them. The amazing thing is, the computer mathematically calculates the purity that would result from every single possible question before it even asks one. So it runs these little simulations. It asks itself, okay, if I split all this fruit based on the question, is it red, what will the new purity of my piles be? And it gets a score. Then it tries another one. What if I split it based on, does it have a stem? And it gets a different score. And right here, you can see that asking about a stem is the clear winner. It creates a much bigger jump in how sorted the new groups are. And that's it. That's the simple, elegant rule at the very heart of this whole thing. At every single step, the decision tree calculates the purity gain from every possible question and just picks the one that does the best job of sorting the data. It's always, always looking for the smartest question.
So how does the tree actually get built? Well, the algorithm doesn't just do this once and call it a day. It's a repeating process. It asks the best question, it splits the data into new groups, and then it treats each of those new groups like a brand new, smaller game of Guess Who.
This is the whole playbook right here. First, it scores all the questions to find the one with the biggest purity gain. Then it picks that winner and splits the data. Next, for each of those new little piles, it starts all over again, asking, okay, for this specific group, what's the smartest question now? And it just keeps branching out, over and over, until the groups are basically pure or it just runs out of useful questions to ask. So, okay, why do we spend all this time talking about a children's game and sorting fruit? Because this exact logic is one of the most fundamental, most widely used concepts in all of machine learning and AI. It's a huge deal.
That simple quest for purity is running behind the scenes everywhere. It helps doctors make a diagnosis by asking a series of questions about symptoms. It helps banks decide whether to approve a loan based on your financial history. It's what's happening inside your spam filter, and it's how companies predict what you're probably going to buy next.
So the next time a system makes some complex decision about you, approving a loan, filtering an email, suggesting a product, just remember the game. It isn't magic. It's just a machine playing a very high-stakes version of Guess Who, and trying at every single step to ask the smartest possible question.